So proportions and triangles, you're just going to be looking for, don't write this down, but you know a proportion is like this. How many pieces do you need to fill in to make the proportion?
3.
1,
4.
2, 3, 4, right? You need a top left, bottom right, bottom right. All right, with these kind of problems with special rules, you have that done for you. It's already separated and split up. You just need to know certain facts before you can do that. So this one says if 3 or more parallel lines. So this only works if 3 lines are parallel. If 3 or more parallel lines intersect 2 separate transversals, then they divide it proportionally. In other words, then they make a proportion. And the proportion is found right here. Okay, this would be the top left. This one would be your bottom left. See? That's your fraction right there, green over red. And then the fraction on the right would be this one. And the fraction, well, that one would be that over, I need another color. Make it. Okay, so if the lines are parallel, then there's your proportion. All you have to do is cross multiply and solve. So let me write that out for you. As a rule, we use the letters for the variables, but when we get into the problems, it'll be numbers. So what goes right here? What's the top left? What's the green one? AB. What goes right here? And what goes right here? And what goes right here? Okay, so all you do is think about this as one fraction and this is the other fraction. So in this case, it's the same thing. You break it up into the 4 side pieces. It doesn't count for anything on the inside. Those aren't broken up proportionally. Only the sides are. So Pn would be part of your fraction, and Pn would go over what? What would be on the bottom of Pn? And M. That's one of your fractions. And then you have on the other side, PV is on top, and what's on the bottom? BQ. Okay? So you think of it like your fraction sign is right in between them. So here's our proportion, and you got your 4 parts, Pn over Nm, and it'll be easier when there's just numbers. Look for the theorems, we want to write it out officially. Pn over Nm. And on this side, what's on top? PV over BQ. Good. Now I just want to tell you that that only happens in one certain case. But here's the thing, it has to be parallel. It doesn't work unless a line inside the triangle is parallel to one side of the triangle. Then it breaks up proportionally. Whenever you hear the word proportionally, it just means you can make a proportion. You can cross multiply and solve. Take the headphones out of your ears, please. And the converse would just go backwards. If a line splits the sides of the triangle up proportionally or into 2 proportions, then the lines are parallel. So it only works if this line is parallel to this line. So I think we already did this part, didn't we? Okay, so any questions on that? There's one other rule, and it's just as easy. The trick is that it doesn't work with anything between them. It has to be on the outer edges. So look at the third one that you had down of the rules. Look for the 4 pieces that would be broken up that we can make a proportion out of. Anyone still writing? Oh. So look down at the other one. Don't mark on it yet because I don't know if it'll be right or wrong, but look at it. See what you think before I tell you. Alright, so now this one. Again, today I had you get 4 pieces of whatever colored pencils or crayons. I had to get 4 of them because there's always going to be 4 sections that you have to look at. It's an angled bisector that's right here. This middle piece is cutting the angle in half, so that doesn't count. That's the one that's cutting. But if the angled bisector divides the opposite side into 2 segments proportionally, you can make a proportion out of all the sides if the angle is cut in half. So it's only the sides that count. So you have one side right here, ST, but this piece is broken up into 2 parts. So the other part of the proportion stops at the W, TW. That's your fraction right there, ST over TW. And on the other side, you have WR on the bottom. And what's going to be the top of that fraction? SR. Okay, it's the 4 outside pieces. The angle bisector cuts in such a way that you have 4 parts that make a proportion. Okay, and they line up perfectly. That's what I love about this section. You don't have to figure out what goes over what. You just look at the picture and you know. ST goes over what? What's on the bottom of the fraction? TW. And SR is on top. What's on the bottom of that fraction? Or WR, either way. Okay? Those are the rules. When you see the word proportionally, think about the 4 pieces that you could turn into a proportion. Okay, and hopefully the 4 colors help you see that. Now down on the bottom, it's the same thing, it's just that it's numbers. So let's do some we're actually solving and it's actual numbers. And it's all there. So what we have to do is find the 4 parts, turn them into a proportion, cross, multiply, and solve. Anybody still writing here? Alright, so for number 1, or letter A, here's your 4 parts. Can you see the division? Let me actually ask you, give me the letters of the 4 parts. Go, what's one of them? FG. What's another 2 letters of the parts? GH. What's another one? And these are in between the parallel lines. That's how you know. It's divided up by the parallel lines. The last part is? So that's your fraction. So right here, let's write the fraction. This part, whoops, sorry. Do one more thing to help you here. Look at this part only. What's on top and what's on bottom? Give me the numbers this time. Give me 5 over 7. And then this side is going to be whatever what? No, the 6 stays on top, just like it is. All lined up perfectly for you already. So it's going to be 6 over x or 6 over kj, whatever you want to use. So it's 5 over 7 equals 6 over x or over kj. Okay, it's all lined up perfectly for you. That's the nice thing. You don't have to figure out what goes over what. You just copy down when you already see the 5 and 6 is on top, the 7 and x is on bottom. Because that is a line that's parallel, and that is the line that's cutting proportionally. So it's not part of the proportion, it's what's dividing up into proportions. So you have 5 times x equals 42, and x equals 8.4. Come on, this right here. Is it 8.4? Talking about right here. Look, right here. Help me out. 42 divided by 5. 8.4, right? Yeah. I'm talking about what I'm writing right here. Okay. Stay with it. I knew 5 went into 40, and that's 2 space, right? You can correct me on my calculator. I knew how to do it in my head. Alright, this one. You can break it up into the colors, or you can just identify it, and you can just see it. Now, in this case, it might help you a little little bit sometimes to rotate the triangle, but we need to make a proportion. This is an angled bisector, which means it's good. It's cutting it into the 4 parts. So let's try, we've got this one right here. We've got this one right here. Now this part stops at the Z. So it goes here, and then it continues on after that to the W. So I want you to visualize what the 2 fractions are. In this case, right here, what goes on top and what goes on bottom? Make my fractions. What's the top? Over. Yep, it's just right there for you. 7x minus 12 over 18. What's the other side of my proportion going to be? 2x plus 3 over 9. Okay, so I'm going to need you guys' help with the calculators because these numbers are kind of too big to do in my head. 2x plus 3 over 9. And we cross multiply it, and we remember to distribute. Got to distribute 9 times 7x minus 12 equals 18 times 2x plus 3. So I can do 63x, and 9 times 12 is 108, isn't it? Please correct me if I'm wrong. 18 times 2 is 36x, and 18 times 3 is that 54?
Yeah.
Thank you. Alright, so I would subtract 36 from both sides. And I would add 108 to both sides. This is just the algebra part. This is just the solving. So I can do this one. 12 is that 162. What's this one come to? Finish solving that. I'll let you catch up. Finish solving that one. Looking for 63 minus 36. What do we get for that one? I can do it faster than you guys are doing calculators. 27? And divide 162 divided by 27. What's our answer?
6.
That is equals 6. Alright, good. Now, let's go back and read the question though. If x equals 6, that's a good thing. But, is it the final answer? You have to plug it in, that's right. The question is, what's v, x, w, and w, z? So you take your x, and you plug it in right here. 7 times 6 is 42. 42 minus 12 would give us an answer of 30 for that one. And plug in a 6 right here. 2 times 6 is 12. 12 plus 3 would be 15 for that one. So don't forget to do that. 30 and 15. This one, it was the same thing. X was where the missing part was, so that was still 8.4. Okay. Turn the page, let's do a few, and then I want to see you practice it. I'll let you do the top part on your own in a minute. I want you to be able to identify all those parts. But let's look at number 7. We're going to do the practice boards in a minute, but I want you to try a couple beforehand. So number 7. Okay, I'm not going to do all the coloring this time. But I do want to make a proportion out of this. I want to see if you can see it. So, look at it carefully. I'm going to cover over this side. And I want you to just focus right here. What's the fraction going to be? That goes on top. 12 minus x over. Good. And then on this side, what's the fraction going to be? 6 on top or on bottom? So you do have to cross multiply. 4 times 12 is 48 minus 4 times x equals 6 times x plus 18. Add 4x to both sides. Subtract 18 from both sides. Cross off, cross off. 10x equals 30. X equals 3. Are we done, or is there more to do? Done. The question says solve for x, so in that case we can stop. Okay, look down at the next one below it, number 9. Okay, this one's slanted. Might make it kind of hard for people to see, but watch this. You can turn your paper and you can just adjust it in a way that makes it easier for you to be able to see it. I'm going to do it this way since I can't turn my screen. I'm going to take this triangle and I'm going to turn it to a way that makes it easier for you to see. Let me turn it this way. There's lots of ways you can do it. If I turn it this way, now you can clearly see this is on top, this is on bottom, this is on top, this is on bottom. You could also turn it this way, and you can set it up this way, where it's 8 over x plus 4, or it's 20 over 4x plus 1. You can turn your paper either way to make that work. All right, I'm going to go, well, since it's here, I'm going to go with this way. I'm going to make it bigger so we don't see the one underneath it in the way there. All right, so now you can make a proportion. Turn your paper if you need to be able to see what lines up with what. So right here, I ignore part of it, and I make a fraction out of that. What goes on top, what goes on bottom. It's in the top right corner, top left, right here. Over. Good. And then in this case, it would be whatever what? Over. Good. And you can realize that both the 8 and the 20 are on the top, or the x plus 4 and the 4x plus 1 are both on the bottom. They line up. Okay, but sometimes you might want to turn your paper. That might make it easier for you. All right, so we have 32x plus 8. 32x plus 8 equals 20x plus 80. And that makes 12x equals 72. And x equals 6. Please correct me if I'm wrong. And since the direction said solve for x, I can be done. Okay, while some people are finishing, look at number 14. See if you can figure out the 4 parts. There's one trick to this one. Yeah, I've asked you to put your phones and your headphones away and off. Number 11. You can see the 4 parts, but there's something that seems to be missing here. That 35 starts here and goes all the way down to here. The x, though, only is in between these 2 parts. So can anybody figure out what this piece right here could be represented by? All right, get this because it's the same every time. This is one thing where like it's the same every single time. Get this, look at this closely. What you do is you take the whole piece, 35, and you take away the piece that you know already. So when you want just that small part, you say 35, the whole thing, minus the x. That's going to come up sometimes, and you have to just see that and remember that. And you take the whole piece minus the small piece that you already know. This one you don't have to do that with because 20 goes from here to here and 8 goes from here to here, and that's fine. But the 35 was going all the way through. Like this one. This one's 12, this one's 20. This piece is x, but what's this piece going to be? 40 minus x. That's something to just memorize and do every single time. All right, so over here we have the 35 minus x, and we have the x and we have the 20, and we have the 8. So let's make the fraction out of that. What's the first fraction going to be? Yep. And what's the other fraction going to be? Over. Okay, sometimes, occasionally, you will get a kind of problem where you have to square the x's and then you have to solve by factoring. We'll review that some more as we go. But this is 20 times x equals 8 times 35. It's not 280, is it? Help me out, help me out, help me out. 280? Yeah. 280 minus 8x. Alright, don't forget to distribute. You might set up the whole thing right, and if you forget to distribute, the answer comes out wrong. So now I have to add 8x to both sides, and 28x equals 280, so x equals